Okay, this video is going to be unpacking the difference between what we describe as a vector and what we also describe as a scalar. And these are two very important ideas in physics, particularly in this motion topic, because it will dictate the way in which you need to represent answers, and it might also represent the type of sort of values that we're being given, or how things are sort of looking for us. So they are two very, very important ideas. Basically, the key difference is that a scalar is what we refer to as something that only has magnitude. Now, the word magnitude can confuse people at times because they sort of think that that's like a thing that we need to find. I often try and sort of explain it that what it really means is that we're trying to find some sort of like value. However, the one thing that we are not finding is we are not finding direction. I guess, as you can imagine, the key difference with a vector is that when we are finding a vector, what we are finding is the magnitude and also the direction. So direction is really, really important for us in terms of what we're trying to do. And what that means is that we might have scenarios where we get different answers for the same sort of question, and we're going to unpack that in a minute. So I guess the question is like, what links to what here? I don't know why that just happened, but we'll just push on. And the answer is that on our scalar side, we're representing things like distance and also speed. And on our vector side, we've got displacement. And we also have velocity. What that means is that if I'm being asked a question, I'm being asked to find distance, I'm literally just finding a number and I'm not interested in the direction. And likewise, if I've got a question asking me about speed, I also don't care about direction. With these two, displacement and velocity, I need to have some information about direction in order to answer the question. So I just want to unpack quickly what that looks like in a few different questions for us here. So what that means is if I had a question, so for example, I'm going to run forwards, and I'm going to run forward 5 meters in 2 seconds. Then I'm going to turn around and move backwards 3 meters in 3 seconds. And if I ask you some questions as a result of this, we will see that there's quite a significant difference between distance, speed, and displacement and velocity. So for example, if you are asked in a question, what is the distance that you have traveled in this question? Well, because we're not interested in direction for distance, we are literally just being asked, how far have you actually gone? And the answer to that question is to say, well, what I've done is I've moved 5 meters and then 3 meters, which means I've moved a total of 8 meters. We do not care what direction you've moved that 8 meters in, so therefore that is the distance because the direction is not important. For the second part of what I'd be asking here is I'd say, okay, well, with that in mind, what displacement have I covered? Okay, and if we look at our displacement, what we are interested in is how far we've kind of gone, but including the direction. Now, for me, I would word that as how far away am I from where I started? So if I started in this position here, and I've been told that I've gone forward 5 meters, and then I've sort of stopped, and then I've turned around and come backwards 3 meters, then hopefully what we can see is that if I started in this position and I finished in that position, the difference between 5 and 3 is going to be 2. And what that means is that my displacement is 2 meters. Now, the important thing that I need to represent here, though, is I need to determine whether that's forwards or backwards. And clearly, the answer is forwards, because I've gone 5 meters forwards and 3 meters backwards, which means I've gone further forward than I have back, and therefore that would be the overall displacement. So you can see that despite the fact that we've got very similar ideas between distance and displacement, I get very different answers for the same question. Now, it gets even more interesting if you sort of compare with C. I'm going to look at, well, what is my average? And it's important to recognize it's an average speed. Now, average speed is going to be represented by distance over time. Given that speed and distance are our scalars, they need to link together in these formulas. So the distance that we traveled was 8 meters, and the time that I've traveled that in was 5 seconds, because it's taken me 2 seconds and then another 3 seconds. and then I would get my answer for that, which would be 8 divided by 5. You can try and put that into a calculator, and once you have done that, you'll find an answer, and it will be in meters per second. So if I put 8 divided by 5 into my calculator, what I will get is an answer of 1.6. It's an average speed, so the unit there is meters per second, because it is literally meters per second. And I do not need to include any sort of direction for that, because again, it's a speed, which means it is a scalar and not a vector. If I then look at a part D to this question, I say, well, what is my average velocity? Then what we'd be saying here is that that is a displacement divided by time, and that's because velocity and displacement are our vectors, and they need to stick together for these questions. The displacement we've already said was 2 meters forwards, and we've said that the time is still going to be the same here, which is 5 seconds overall. So we've got 2 divided by 5, and if you put that into your calculator, you'll get an answer of 0.4 meters per second. But again, this needs a direction because it is a vector. So I'll get 0.4 meters per second forward. So you can see that I get some pretty clear differences between the vectors and the scalars, and it means that it is very, very important that we distinguish what type of thing you are looking at when you're looking at these questions. Otherwise, you might get the incorrect answer for what we're trying to do. Now, I can hear you asking one question, and that's about this thing, something I mentioned in the previous video, and that is, what is the deal with acceleration? Remember we said acceleration was measured in meters per second per second. And really, the answer to that is that acceleration can be considered, let me start that again, can be considered both a scalar and also a vector. And it's because it depends on whether we're dealing with speed or velocity, and hence distance or displacement. So if we were looking at the question over here, so when we're dealing with average speed, for example, if I was using that value, the average acceleration could be considered to be the change in speed divided by time. Or if I was looking at it in respect to velocity, then it might be the average velocity divided by time, or the change in velocity divided by time. So long story short, acceleration is really dictated by what values you already have in the question before getting to that point. Now, the other thing to consider is that this is obviously like a sort of one-dimensional problem, but we might have scenarios where we have two-dimensional problems. Just as a quick sort of basic sort of one to just get through that, what we might have is a scenario where I might go, say, 3 meters forward, for example, and then I might choose to go 4 meters to the right. And as a result of that, I might be asking, well, what's my distance and what's my displacement? Now, what we would look at with this is we would say, okay, well, distance, remember we've said, is that the total number that you've sort of traveled, regardless of the direction that we go in, and that's 3 plus 4, which would literally just be 7 meters. The displacement, though, is a little bit different because it relies on where have I started and where have I finished. And you can see here that this is a right-angled triangle when I've actually brought that together. Now, those familiar with some pretty basic mathematics would know that that's going to be a Pythagorean sort of scenario that we're going to be dealing with. And as a result of that, we would go to solve it. It's also a fairly famous triangle in terms of the 3, 4, and 5. But if you did a squared plus b squared equals c squared, you'd have 3 squared plus 4 squared equals 5 squared. X squared, because we wouldn't know what it was. 9 plus 16 equals x squared. 25 equals x squared, and therefore x would be equal to 5. So long story short, we would find that this has a displacement of 5 meters, as opposed to the distance of 7 meters. However, one thing we would also need to explain is what direction it is. And what we'd be looking to do for that is represent an angle here. We could use trigonometry to find that angle, and then we would explain that, it's at that angle as a result of sine, cos, and tan, and we'd have some sort of direction to go with it. So it is important to distinguish when you're solving these questions whether you're dealing with vectors or scalars, because it is going to dictate how you go about the calculations that follow.